You can go, Lisa, now.
Okay, I think that we can start. We are already quite many online. So a very good Friday afternoon from the Embassy of Finland, New Delhi, India. My name is Dr. Liisa Toivonen. I'm Counselor of the Science and Higher Education Policy. Ladies and gentlemen, scientists, eminent speakers, companies, and all who you are interested about the space. I have a privilege and great pleasure to open this Team Finland Knowledge and Indian Space Industry Association's jointly hosted webinar on future of the space technology and science. And before giving the floor to In Space and other speakers, I use some minutes to lead us to the topic from Finland's perspective. Humans have always been really fascinated by space, and not least today. A desire to explore the unknown, space is seen as the ultimate frontier, a source of wonder and scientific discovery, and also a potential next step for humanity. And that is what we are going to discuss today. Finland's renewed space strategy to 2030 targets to respond to the opportunities and challenges opened by the transformation and fast development in the space domain and operational environment as well. The strategy focuses particularly on the utilization of space services in society. By utilizing space services, societal functions can be enhanced and streamlined, and entirely new applications can be adopted. We can't even know what all kind of applications in the future space might provide for us. As society's functions became digitalized, Earth observations, time and location information, and ubiquitous communication links are fundamental elements on which developing applications can rely. Investments in research, development, and innovation activities are increasing heavily. In Finland only, there are more than 200 companies already operating in space sector. Many of them have grown from startups to internationally significant players. Finland has become one of the Europe's key investment destinations for new space businesses. Finnish space expertise comprises cutting-edge space and atmospheric research, as well as competencies in space technology, for example, electronics and software. As an example of Finnish know-how in satellite database services, our service companies operate, for example, in the fields of forestry, agriculture, smart cities, maritime services, and, for example, International Pegasus Space Weather Center is also located in Finland. The same development is taking place all over the world, not least here in India. Today we will hear more about these possibilities and development during this webinar, and also possibilities to cooperate. This seminar is to provide us an understanding what all kind of possibilities to almost any sector space can provide, and how important it would be to join our forces in research and innovation to find new fascinating possibilities, not only for Finland and India, but everybody. And now I would like to hand over to Director General Anil Prakash, and he has accepted to kindly chair the rest of the seminar, because I have had bad flu for more than a week now, so my voice is not much coming out. So you are welcome, Mr. Prakas.
Yeah, thank you, Dr. Lisa, for that very insightful.
Some technical issues.
There's some technical issue with Mr. Anil. He's just joining shortly.
Okay, great.
Yeah,
But maybe we can then move to our next speaker already.
Yes.
Our next speaker for opening remarks from Indian side is Director Dr. Vinod Kumar from InSpace. So, Dr. Vinod Kumar, the floor is yours.
Yeah, thank you, Ms. Lisa. So I will start here. Thank you very much. Namaste and good morning, good afternoon to all our esteemed colleagues, dignitaries, industry leaders, and friends from Finland. I'm very happy to see over 100 people have already joined this good webinar on future of space technology and science. It's a distinct pleasure to offer this opening remark on behalf of InSpace, I mean Indian National Space Promotion and Authorization Center, and India at this critical and timely India-Finland space technology and science event. Your presence here today signifies a shared vision, a recognition that the future of space exploration technology is inherently collaborative, bridging geographical distances with a common scientific spirit. India and Finland share a bold vision of harnessing cutting-edge technologies and space innovations to tackle global challenges and drive sustainable growth. We say in India that space tech for last mile connectivity. Our strategic document reflects this perfect alignment. We understand that Finland has a national space strategy that sets the ambitious target of becoming the world's most advanced space-faring nation or space operating by 2030, emphasizing applications across security, telecommunication, and climate change. We at India are also carried out a revolution in space sector reform. As you know, Indian National Space Sector reforms were carried out in June 2020, where private sector were permitted to carry in any space activity under the sun in the space sector, and InSpace was formed. The full form is Indian National Space Promotion and Authorization Center. We were operationalized in June 2022, and since last 3 years, we are working on 7 pillars to develop space ecosystem in India. This starts with the government main role is the clear policy, which is defined. Indian space policy was brought in 2023 with a clear demarcation of the activities that has to be carried out by Indian Space Research Organization, New Space India Limited, Indian National Space Promotion and Authorization Center, which I represent, and non-government entities. They were the new actors which have started working in the space sector and carry out end-to-end activities, any activity in the space sector. So what we are doing for this, in addition to bringing clear policy perspective and norms, guidelines, and procedures, we have revolutionized the foreign direct investment. Now FDI upper limit is 100% in any sector of space, but they are sectoral cap. Like satellite building, it is 74% automatic route, and beyond that is also possible through administrative route. For launch vehicle, it is 49%. automatic route. Beyond that is also possible through administrative route. And in subsystem manufacturing, it is 100%. Please note that before this reform, the FDI was through administrative route only. The space sector is very tax savvy and money deep pocket sector. So for that purpose, we have transferred over 100 technologies from ISRO to the consumption by the private sector. Access to finance is another this thing where we have worked out many schemes. We have already implemented it. We start from pre-incubation entrepreneurship development program, where we take to them to do the proof of concept and paying them around 10 lakh to demonstrate it. After that, we have seed fund scheme where up to 1 crore grant in aid we do. 1 crore is around 120. So it is around 1 million, more than $1 million. Then if comes to the technology adoption fund of around $65 million, 500 crore to develop the technologies from TRL4 to 7, 8, 9. We have that. We have adopted another 1,000 crore VC fund. That is 125, $128 million kind of thing. That has come. Another important part is access to infrastructure. The government has opened the infrastructure to use ISRO infrastructure to be used by private companies. For that, they have to apply to InSpace, and it's an online process. Another important is the aspect is the capacity building program. We have developed and designed 11 courses, short-term skill development courses, and we are assessing an awarding body. We are conducting them regularly, roughly 1 course a month. And second cycle has started of these courses. They cover full spectrum of space activities, be it launch vehicle, propulsion system, satellite making. B is the brain of the satellite making. I mean to say flight mechanics, attitude orbit control, application, space data product and services, entrepreneurship development. We have implemented these and they are going well. The class is within 1 week. Another important pillar which I say is the student development of the next generation to take up space career is through our space technology adoption by academic institutions across the country. I'm very happy to tell over a dozen, 15 has already adopted space technology at various levels, BTech, MTech, and PhD even. There is a good demand for these courses from India. About a dozen institutions and universities are in touch with me to adopt them. And we are helping them, not only in adoption, providing expert lecture, but we provide these students experience of immersion training at our technical center. We have a technical dedicated center to be used by non-government entities at Ahmedabad. There we give opportunity to students to have 1 week immersion training there and learn the nitty-gritty of the space sector. Another thing is we are providing opportunity for these students at private companies. I'm very happy to tell you that our friends from private industry has a huge demand for interns. Over 600 students are required by them. And I'm very happy to, they are paying them more than 50% are paying them also. This is not free internship rather. Then another to impart practical training to them, we have designed and developed model rocketry and can-size satellite competitions for them. This is not can-size satellite, it's 7 new satellite in fact. If you see around, we have 160 plus applications for this. After scrutiny, around 75 teams for CANSAT and model rocketry are competing this month and from 26th to 30th at Kushinagar, Uttar Pradesh. So this covers full spectrum of activities. And last but not the least is the authorization and supervision. All these activities are being carried out in a supervised manner, wherein we supervise them and ensure that quality is maintained. We are working with Quality Council of India to give them quality certification in a very systematic manner. Of course, we are acting as a single window agency to authorize them and to take interdepartmental clearances. Once they apply to us, all clearances are put in place in a defined time frame. Friends, coming back to India-Finland partnership, this alliance between two rapidly growing commercial space ecosystem is very important. I'm very happy to know that you have 200 companies already working in the space sector. I am pleased to tell you within a short span, we are having 370 plus new startups that are working in the space sector. We are rapidly growing economy in space with another 200, 300 large, medium and small enterprises. We have many vendors that will go in thousands. So deep tech is a very important area where we should work together to develop the technologies. We understand that Finland has a global leadership in quantum computing and robust AI ecosystem. This is a natural fit for India's massive data generation capacity. Recently, ISRO has released its Chandrayaan data and other scientific data for analysis by the academia and industry. Health, pharmaceutical, and food security for space is also another area which we see a lot of synergy and collaboration opportunities. Advanced material science and supply chain is another area where we can work together and develop the more resilient and cost-effective satellites and launch vehicle. Friends, the success of the partnership between the two countries will depend upon active engagement with both academia and industry. I urge you to use this platform to strengthen academia and industry partnership. That is very important, so that we can carry out the joint research between top institutions in India, those who are working in space sector, and their Finnish counterpart as well. We should identify joint R&D and innovation opportunities. We conduct the space days where industry from both the countries can present virtually their capacities and capabilities we can identify. I propose that we can plan one space day virtually with Finland, where we can give the opportunity to select companies and give them opportunity to pitch their capacities. We have conducted over a half dozen already, and there is many more are in pipeline. So I understand that by working together, leveraging India's launch capability, large talent pool, with Finland's advanced digital and deep tech innovation, we can effectively address global challenges in the space sector. Thank you, Kaitos.
Thank you very much for really good and inspiring, interesting opening speech. And now I hope that Director Anil, Anil Prakash is already here. Are you?
He is Director General.
Director General, yes, Director General Anil Prakash, are you here?
Thank you, Lisa.
Okay, now I'll hand over to you now.
Thank you. Thank you, Lisa, Dr. Lisa, for your very good opening word, and followed by Dr. Vinod, the illustration about how progressive is the India marking journey and the collaboration unfolded for both India and Finland. As India and Finland cooperation in space is founded on shared value of innovation, sustainability, and peaceful use for outer space, the memorandum of understanding between India and Finland on cooperation in the field of peaceful use of outer space provides a formal framework for advancing scientific collaboration, technology exchange, and institutional partnership. This collaboration gains further relevance when viewed against the backdrop of India's rapidly evolving space ecosystem. which offers multiple entry points for meaningful bilateral management engagement. India's space ecosystem today spans the full value chain, upstream, midstream, and downstream, from launch vehicle and spacecraft, bus development to payload design, satellite constellation, and advanced analytics. The sector reflects robust capability and depth. In parallel, India R&D and integrating frontier technology, artificial intelligence, novel material, miniaturizing satellite, design quantum communication, and cyber resilience. A prominent illustration of Indian technological ambitions is Gaganyaan program, which has become a cornerstone for human and life science research in space. The mission focuses on human health in microgravity, life support system, radiation biology, and biotechnology, relevant to long duration of mission, experiment on model, organism, food storage, nutrition, psychological adaptation, and generating not only mission critical insight but also dual use innovation, which direct terrestrial application, the biotechnology, nutraceutical, and remote healthcare delivery. This expanding research agenda demonstrates how India's space efforts are increasingly interdisciplinary, innovation-driven, and globally relevant. For partners such as Finland, this evolving landscape offers multiple dimensions for collaboration in their technical breadth, in launch capabilities in manufacturing and data-driven downstream services, coupled with Finland's scientific expertise, open three categories of high-value cooperation. Number one, co-development applied R&D in life science and food in space. Finland's strength in biotechnology and food technology and bioterms align closely with India Gaganyaan-driven research agenda, spanning control, environment, nutrition, food preservation technology for microgravity, and telemedicine solution for true health. These are not merely mission enabler, but commercially viable research output with application in food security and precision agriculture. Second, sensors, materials, and small satellite partnership. Finnish excellence in advanced materials, sensors, and secure communication hardware complement India's growing small satellite and constellation ecosystem, opening pathway for joint design, co-manufacturing, and component exports. Third is data analytics and climate and Arctic application. Finland renowned capability in environmental monitoring, polar research, and climate modeling can be synergized with India's large-scale Earth and climate modeling, can be observation and data platform, leading to joint prototype and pilot projects in coastal resilience, agriculture analytics, and pollution monitoring. As India embarks on new era of ambitious mission from Gaganyaan to Chandrayaan-4 and beyond, it is evident that no nation can pursue its space aspiration in isolation. The complexity of upcoming mission demand not just government to government cooperation, but also robust to business linkages that translate scientific exchange into tangible outcome. Such collaborations are backed by progressive reforms such as India Space Policy 2023 and the liberalized FDA framework, as mentioned by Dr. Vinod Kumar in earlier. India today offers one of the most open and facilitative environment for space collaboration. In space, serve as a single window interface for private entity, while 100% FDI is permitted in satellite component manufacturing and substantial automatic route investment is allowed in satellite operation, launch vehicle development. These reforms ensure faster authorization, transparent licensing, and clear policy emphasis on co-development and export-led growth, creating a predictable landscape for global partners to engage in joint venture and technology transfer. The next phase of Indian-Finland space cooperation must move beyond framework to forge enduring industry partnership and innovation ecosystem. By connecting our research into institutions, startup, and industry, we can co-develop technology that advance human progress. With this note, I have a number of experts who is going to throw light on the various topical subject, and I would like to invite our next expert to deliver his talk is Professor S. Satyan, who's a professor in Department of Mechanical Engineering, IIT Madras, and we welcome Professor Satyan for your thematic discussion. Over to Professor Satya.
Hi, good morning, good afternoon, everyone. Can you hear me okay, Dr. Anna? Yeah, okay. Yeah, so first of all, thank you to the SIA team for inviting me to this webinar. I'm happy to participate in this. So just to give a small background about me, I'm a professor in the Department of Mechanical Engineering at IIT Madras. IIT stands for Indian Institute of Technology Madras. It's one of the premier institutions, top-ranked premier institutions in the country. So I've been here for about 11 years now at this institute. My training has been in the area of manufacturing science and engineering. So that's basically what I got trained in. And the reason I'm here talking about space in the context in this webinar is for the last about 4 or 5 years or so, we've started a center here called as the Extraterrestrial Manufacturing Research Center. So the idea is how do you develop, how do you manufacture things in space? So that is the theme behind this center's research activities. For a long time, we've been making manufacturing things on the Earth to launch into space. It could be rockets, it could be satellites, and so on and so forth. Now the question is, can you manufacture some of these things in space itself? Can you have factories in orbit? Can you have factories on the surface of Moon or Mars, for example? Or if you're on a long journey space mission and you want to make some things on board, for example. So what kind of manufacturing technologies would suit those space environments? So that is sort of the question. Of course, this is not a new area. It's been there for a long time. Several countries, including Europe and US and Japan and Russia, China, they've been already doing a lot of things. Especially in the International Space Station, there's been a lot of testing that's been done. And even before that, microgravity experiments have been done on drop towers on the Earth. People have tried to understand what is the effect of gravity, for example. So in the Indian context, this is fairly new to India, and we started some of this activity here. In our campus at IIT, we actually have a microgravity simulator. It's a drop tower platform. We have that. And our team has done some experiments on materials processing, for example. The drop tower simulates for a very short duration of time, 2.5 seconds or so. So you have to be very creative in creating experiments that would suit this environment, for instance. We have done experiments, for example, on metal droplets. So when you melt materials and it drops down, for example, what is the effect of gravity on such a drop? And of course, such metal droplets are used in welding and 3D printing now, perhaps in other contexts as well. So we are doing quite a bit of experiments on that. We've published as well in this area. So the idea is to see, when the metal droplets fall, they just don't fall only due to gravity. There are so many other electromagnetic effects that is there, surface tension effects that are there. So if you look at welding or in the context of 3D printing, for example, so when that gravity force is switched off, what happens? So and we only have, as I said, we only have a 2.5 second window to observe that. This is just one example of an experiment that we have done. So again, going back to this concept of manufacturing in space, you can manufacture things in space for space use, that is in space itself, or you can manufacture things in space and bring it back to Earth. That sounds even more weird because imagine factories in orbit. Your satellites are no longer satellites. They are, in the traditional sense, they are now factories. So you can send raw material to the satellite. The satellite has machines that will process your material, and then you can retrieve the material, bring it back to the Earth, and use it for commercial purposes. Yeah. So the idea is, why would you want to do that? Why would I want to send raw material to space, put a factory there, and bring it back? So the concept is, when you don't have gravity, there are certain things that are very interesting that happens when you do materials processing, when you do bioprinting, for example, and things like that. So the idea is to exploit microgravity to make better materials, better products that could serve us better. Some of the examples are, semiconductor crystals, for example. it's possible that when you grow crystals from the vapor state, especially, or even liquid state, for instance, the lack of gravity could actually help you better to get better defects. I mean, control defects or less defects, for example. So that is one space where people are looking at, and they think it's commercially viable to send raw material, make it there and bring it back, for instance. The other area is optical fibers. Optical fibers is one place where people are trying to see if gravity effects can be used to make better optical fibers, particularly this class of heavy metal fluoride glass materials, for example. And here you have the opposite problem, that is, I don't want it to crystallize. I don't want it to form crystals. It should remain amorphous as I heat it and cool it down, for example. So here again, gravity actually aids in forming crystals in this case. So if you switch off gravity, can you get a better amorphous structure, for example? So we have done a lot of ground experiments in optical fibers, for instance, and we're getting ready for a parabolic flight experiment that to be conducted. So we have so my team consists of few PhD students, few engineers. We have a postdoc who do this kind of experiments. So that is one other area where we are working on optical fibers. In the space of crystals, which I was mentioning earlier, diamond is of interest to us. So diamond is something we're looking at. I'm already part of India Center for Lab-Grown Diamond in our institute, and we're trying to see if we can actually make better diamonds in space. Not for the purpose of jewelry or other things, but more, diamond as a crystal could be useful for very, very interesting applications like quantum, for example. Quantum sensing. So if you can actually make very ultra pure crystal, defect-free or defect-controlled diamonds, actually, I should call it like that, because we want defects in diamonds, but controlling the defects is quite a bit of a challenge. So that is something that is of interest to us. The other space there, which is useful for manufacturing in space and bringing back to the Earth, is bio. When you grow organoids on Earth, you have the gravity pulling the cells as they are growing, and it collapses the cells and so forth. And when you don't have gravity, you can actually make better organoids in space. I'm not an expert in that, but I have some colleagues in my we have a department of biotechnology that there are a couple of people who are interested in microgravity effects on tissues, tissue growth, for example. And I'm told that pharmaceutical industries have a lot of interest in growing organoids. So if you can actually do that in a reasonably cost-effective way, they could be interested in that, for instance. The other entire topic is manufacturing in space for space, which is, so if I land in, if India lands in moon, we are discussing with ISRO to see if we can have a Chandrayaan mission that can analyze the regolith or the sand that is there on the surface of moon or Mars, and we can extract things like oxygen or silicon carbide or other ceramics materials that we could extract and use it, for example. So using the regolith that is available on the surface of moon or Mars and making structures out of it is of interest to us. I have a colleague in my civil engineering department who's already made concrete out of this Martian soil, for example, without the use of water. So you don't have water, but you have a lot of the soil. What other chemicals can I mix, for example, with this regolith? And if you can make these concrete blocks, will it withstand? Will it have good strength, and so forth? So using regolith is for various purposes. Developing technologies that will use this regolith would be of interest for space exploration, especially human habitats on the surface of moon or Mars. So these are some of the topics that we're working on. So in terms of collaboration with Finland and India, of course, academic collaboration in this area would be very welcome. We have started on a few footsteps here, so baby steps, I can say. So if Finland is interested or researchers in Finland are interested in collaborating in this area, I would be very happy to work with them. Or if there is any interest where we could work with space agencies also, along with not just university collaboration, but clearly identify some products or something that could be useful for both the manufacturing in space for space or manufacturing in space for Earth. So that would be very interesting for us. So with that, I'll stop here, Mr. Ranil. Yeah.
Thank you, Professor Satyan. I think you touched upon a very relevant point, and in my comments also I mentioned about the life science and especially those medicines and healthcare for our astronauts are very important, and both this country, Finland and India, can work together with our thing, and I think this is a very important aspect. Thank you very much, Professor Satyan, for highlighting that. Now this is for inviting an expert, Dr. Anila Kilpua. She's a professor at University at Helsinki, Finland. So over to Professor Anila.
Hello, thank you. And I had some slides I could share, so I hope that is working. I will try. Let me check. Hello, can you know, I'm checking you can see the slides in the presentation mode. Great. So thanks a lot for inviting me to talk in this very interesting webinar, and I'm giving the brief overview of the space activities that we are doing at the University of Helsinki, where I work with. So we have here quite a large group of the people in our space physics team. We are having 4 professors shown here. So there's Minna Palmroth, me, Adnan Osman, and then Lucille Turk. And then we have also the emeritus professor Hannu Koskinen. We have 6 university lecturers and then 12 postdoctoral and PhD students, and then also several students doing the thesis, master and bachelorette thesis. And I'm presenting here our Center of Excellence. So the Research Council of Finland has this several year prestigious like consortium, and our consortium is studying or called like research in sustainable space. And here you can see who are contributing in addition to us. So Minna Palmroth is leading this CEO, Center of Excellence, and we are here like 5 team leaders. So Minna is leading the modeling team, I'm leading the observation team. Then from the University of Turku, Rami Vainio, who is also the vice leader of this consortium, he's responsible of the instrumentation. Then Jan Brax here from the Aalto University, he's taking care of these spacecraft platforms, and then Pekka Janhunen from the Finnish Meteorological Institute is investigating in particularly this electric sail that can be also used as a plasma brake, so a device or innovation that is designed also to change the spacecraft orbit and then bring them safely down. And the aim of this our consortium is to bring together space science and technology specialists. We are developing a resistant CubeSat or nanosatellite platform and novel instrumentation to do space science. And then scientifically, we are aiming to have a deeper understanding of this very difficult, challenging space environment where these satellites are operating. And just here a small reminder that in Finland we have one of the leading countries for launching and developing and designing these small satellites. So up to now we have our 25 satellites that have been launched. So there are many from the Aalto University, also the first Finnish satellite that provided actually excellent 7-year observation from the space. Then ICI, they have this revolutionary this radar that they can do this Earth observation. Then our Center of Excellence, it's developing this CubeSat. So we launched one a few years ago, but unfortunately after a few weeks in space, we lost the signal. But now we are soon launching a new version of that spacecraft. And then what we are doing at the University of Helsinki, we are basically doing research of the whole Sun-Earth chain and then also some other planets as well. So we are looking at the solar eruptions, sun's corona and solar wind, this ionized plasma flow from the sun. We are looking how the solar eruption and the solar wind are interacting with the Earth magnetosphere, responses down to the ionosphere, and then this space weather, that is this key element that is like making this environment so difficult for the satellites to operate. And what we are focusing on mainly is the fundamental plasma physics. So we are studying these like basic plasma physical processes related to these phenomena. And about our key methods and measurement, we are using data from many of these international big missions like Solar Orbiter, Parker Solar Probe, MMS, Cluster, Pepi Colombo. Then also using small satellite data, many ground infrastructures like magnetometers, radiometers, different type of the radar. We have a lot of different models. I will soon show a few examples doing the high performance computing, for example, in Lumi facilities in Finland and Euro HPC, and then are increasingly applying different kind of the AI and machine learning techniques. And for example, our team is hosting a unique modeling set for physics-based simulation of the erupting coronal magnetic fields to like model these solar eruption when they are forming. So here you can see the surface of the sun, where's the sun magnetic field. So these black and white regions are strong magnetic fields. And the problem is that higher up in the solar atmosphere, we cannot measure the magnetic field. So we need to model it based on these surface observations that are all the time available. And here's the still figure from the simulation. So again, seeing here the magnetic field and then these twisted magnetic field lines that are marking the solar eruption. And then we are modeling how these eruptions are propagating from the sun to the earth or other places in the heliosphere. We have this heliospheric model Euphoria that we have been developing jointly with KU Leuven, and we are also making novel flux rope models, these solar eruption models into this model, so that we can in particular estimate that how the magnetic fields are, because that is one of the most critical part of the predicting this space weather. So here you can see like looking top down to the heliosphere, where the this blue dot is actually Earth, and this is here marking the position of the sun. And you can see here this eruption coming, and then these kind of the models can be used to investigate that what planets, when and how they are impacting, and then also extracting the or giving estimates for the parameters. Then one thing is to look at how these space weather storm in the Earth environment are forming. So that one, Minna Palmroth, she's leading this development for many years of this world's most accurate solar wind near-Earth space simulation called Glaciator. So that's kind of this kinetic hybrid simulation that allows looking really in detail these fundamental plasma physical processes that are governing the solar wind magnetospheric interaction. So for example, they can follow and study different kind of the plasma waves that are propagating through this whole system, and they can study these explosive energy releases in the magnetar tail of the Earth near space environment that are then powering this space weather. Then we are studying the Van Allen belt. So these are these regions of high energy electrons and protons that are trapped in the Earth magnetic field from distances about 500 kilometers to the geostationary orbit. And these high energy, in particular high energy electrons, they are sometimes called also killer electrons because they can be very dangerous for these satellites in space. So getting the improving understanding of how these particles are here moving in the Earth magnetic fields. So these spiraling things here are these electrons and protons that are circling and bouncing and drifting in the Earth magnetic field. And the dynamics are not understood scientifically well at all. So getting better understanding how the fluxes of these high energy particles in Van Allen belts like vary in response to the solar wind driving, then we can get better space weather forecast, and we can then better forecast the environment or the conditions that the satellites are orbiting the Earth. Because even like one single high energy particle can be damaging the satellite instrument, or it can be these longer time accumulated effects of the high energy particles that are affecting the satellites. And then these we also quantifying how these particles from these Van Allen belts are precipitating to the upper atmosphere. So how these, so you have these particles here on this geomagnetic field line. They are encountering different types of the plasma waves that are then scattering them, and they are hitting our atmosphere. And there they can like affect the dynamics and, for example, cause ozone destruction. And we have this particle telescope called PATE, developed at the University of Turku, and that is planning to measure these precipitating electrons with the unprecedented high pitch angle resolution, meaning that we can get much better handle of that, how they are like kicked away from these belts. And then we also studying how these most extreme storms are forming, and particularly that what are the effects. So we often discuss this Carrington storm as a reference point. That was this big magnetic storm that occurred in 1859 September. At that time, there were very little technology that could be damaged. There were some problems with the telegraphs, and the auroras were seen all over the place, all over the world, like in Hawaii and Cuba, for example. And that kind of the storms, they are occurring roughly once per century, but they are basically would be happening anytime. And there was Minna was leading this Carrington project that was looking the effects, like getting some results shown here that power grids in Finland would hold, but many of the satellite signals would be lost during the storm. Commercial satellites are in particular at the great risk, and for example, air traffic must be halted and navigation lost during the storm. And there's one example of this type of the storm that occurred in July 2012. So this is the sun here, this shows the earth, but this very, very big eruption, it actually went a bit away from the earth, so we missed that very big storm. It impacted another satellite about the same distance, so we were able to measure its properties. And then we are using in the team also widely this observation from the Bepi-Colombo mission that is on its way to the Mercury. It's carrying a Finnish particle and X-ray instrument called SIX, and that is one thing that we can do there is that we can investigate the magnetospheric processes of Mercury in extreme conditions that could then help us also understand how Earth is behaving when these most biggest eruptions are launched. But yeah, that was everything I had, so thank you.
Well, thank you. Very interesting, Dr. Emila, for thinking, and I think it is a very fascinating work you are doing at the University of Helsinki. You are maybe aware that we have a Aditya L1, which is placed to study movement of sun. I believe there must have been some cooperation going on with the research, and if not, I think there is definitely a way forward with the data emerging out from Aditya L1 can be used for your studies and further. So we need to look at into it. And I think it's a very and space weather forecasting is another very strong area where I think you have been working for. That's really very encouraging. This area we definitely have definitely look for some collaboration and some cooperation in that. Thank you for very much, Dr. Emila, for your presentation. And now I would like to move. Thank you very much. And now I'd like to move to Mr. Srinath Loka Subramaniam. He's the Vice President of Sales at Reorbit. We are proud to say they are our member, and it is Finnish company, and they're a fantastic good job in India. So over to Srinath.
Thanks, Anil, and hope you can hear me audible. Namaskar and good morning and good evening in whichever part of the world we are in. As Anil rightly said, we are part of SIA, and Reorbit is a Finnish satellite manufacturer. We are very unique in what we do. We provide sovereign capability. We provide sovereign connected systems. So we build satellites that can connect between different orbits, LEO, MEO, and GEO. And the idea is to enable a lot of countries with sovereign capabilities. Currently, with the situation that we are facing in the geopolitical area, there is a need for every country to defend their sovereignty. And this is the ambition of Reorbit. And going into Finland and India, Finland has been a country known for research. So we all know Nokia and we used our 1100s and 3100s. So Nokia has a very strong foundation on research. And Reorbit was established in 2019, and we are headquartered in Finland from 2020. And we have a very, maybe one of the biggest manufacturing centers in Europe and the biggest in Nordics. What we did is we took over an old Ford manufacturing facility where they used to manufacture the T model cars. So the analogy is like you would like to manufacture satellites similar to the T model cars. So currently we have a 1,500 meter square clean room, and we are doubling it to 3,000 meter square. And we build small geo satellites. So we are in discussions with various countries to provide them with the small geo satellite capability. And since this discussion is about Finland and India, Reorbit as an Indian presence, we are established in India. And we are working closely in India to scale up our operations in India. So ideally, we have the research and the development focused in Finland at this point of time. But the ambition is to move the research and development and scale the product in India. So currently, we are registered in Hyderabad, but we are planning to open a couple of we are planning to open an office in Bangalore and then have it as a global delivery center, building satellites, architecting satellites, and servicing the entire world. With respect to technology, again, geostationary satellites are considered to be massive, big satellites providing continental coverage. So we are looking at somewhere around 4,000 kgs or 5,000 kgs. We have done some innovation there wherein we have brought the total volume of the satellite to less than 1,000 kgs. And with this, we are able to provide sovereign capability. So just for example, a Reorbit small geo satellite can provide a dedicated capacity for India and provide somewhere around 20 Gbps of capacity on Ka band. As we said, we are a secure comms provider, so we can provide inter-satellite links between LEO, MEO, and GEO. Currently, we are doing a European Space Agency funded project where we are trying to provide intelligence in a very limited time. So this project is quite interesting and quite innovative in Europe, where we have a optical imager on the satellite. We have an onboard processor, and we also have an inter-satellite link. So the ambition is to take an image of Earth and then process it quickly, get intelligence on board, and then deliver that image quickly using ISL links to the ground. We are also testing space-to-space ISL also, but not as on our own, but through partnership. So on the whole, Reorbit is a technology company. We have a lot of innovations and a lot of advancement that we have done, and we would like to carry on that innovation focused in India and grow in India. So with that, I think I've covered pretty much about Reorbit. And just on a final note, we are very closely working in the Indian ecosystem. We are working with ISRO very heavily. And we are planning to launch 2 micro geo satellites in 2028. And we are planning to launch it. And we are in discussions with ISRO for launch as well. So again, this is going back into the relationship that Finland and India has, and also riding on the heritage of Indian space ecosystem and Finnish research and development. Hope that gave you a very clear picture of what we do, and happy to pick questions, if any, later during the day.
Thank you, Srinath, for giving an overview of what Reorbit is doing, and fantastic good work is done by you. And there is a lot of area for cooperation with Finland and India. Thank you very much. Now there's a time to move to Mr. Shreyas Birji, who is the Vice President with Business Strategy at Dekantra. Over to Mr. Shreyas.
Thank you, Dr. Prakash. Good morning, good evening, everyone. Dear Dr. Lisa, Dr. Vinod, thank you so much for the opportunity to speak today. And it's lovely to see someone familiar faces as well. To give a brief introduction, I'm Shreyas. I head the business and strategy for Digantara globally. We are a space surveillance and an intelligence company building infrastructure for easing space operations and space traffic management. What we do lies across the spectrum from, let's say, data generation to data processing and analytics. Uh, since we are mainly focused about cooperation and the work that's going on to building new critical capabilities, I would love to touch upon the work that we have been doing to give you some insights in terms of the kind of technology that we are building for enabling the space surveillance side of things. Um, Touching upon on the upstream side of things, as Digantara, our expertise lies in space-based systems. So we work across the spectrum, electromagnetic spectrum, to provide enhanced information to customers and also comprehensive information. Now, when it comes to space-based sensing, there are a lot of challenges, be it including the visibility, the speed at which the object travels. So it's important for us to look at how we design the sensors so that we are able to track it not only effectively but also accurately. And that's where we come in. So our capabilities, or rather where our significant effort lie, is towards building electro-optical systems, be it VNIR, MWIR, or LWIR systems. We build everything in-house. We put efforts to not only develop the optical systems, but also focus on designing the lenses altogether internally. By that, what we have, what has resulted is that the performance of the systems have almost increased by 5 times than what is out there in the public. We're able to build better optical systems that not only have ability to see things and to meet the current requirements for space surveillance capability, but also cater to other demands and other verticals as well going in. Going a bit deeper about the capability that we have been doing looking forward is that how do we track objects that are usually not seen through your regular electro-optical systems that are currently out there in the market. How do we track objects that are obfuscated, who have, there's a variable light condition. So how do we ensure that we are able to track these objects is also some of the problems that we have been solving on the sensor side of things. Now, when it comes to space surveillance, it's important for us to have a comprehensive understanding about what is happening in orbit. Now, that means that not only understand the position of the object, but also characterizing how the object looks, how the object is behaving. That also plays a very important role. But also, to understand the space weather better, because space weather has a significant impact on the orbit of the object itself. So looking at ensuring we provide a comprehensive information, at Digantara, we have sort of significantly invested efforts in not only fine-tuning, let's say, the optic side of things, but also working towards understanding space weather better. So we have been involved in a lot of analyzing data sets, not only from electro-optical sensors, but also, let's say, data from radars to understand understand space weather better. And that sort of helps me to segue into my next part of the research activities that we do is predominantly focused on data fusion side of things. Now, in space domain awareness or in space surveillance, right, one of the things that becomes very, very important is how do you take two disparate data sets and fuse into one to have better understanding about what is happening in orbit. Now, with that in mind, one of the major activities that we have been taking internally has been how do we fuse multimodal data sets to have better understanding, be it understanding on the lines of sensor level, at the measurement level, or at the prediction level. So we do data fusion across multiple levels, and to ensure that at the end of the day, when the operator is using the data, they have the best information available to them. That becomes very, very important. Now, this brings to the picture as to the state of the industry or the state of the orbit that we are in. Now, up until recently, we were about 3,000 satellites in orbit. Now we are targeting about 13,000 to 14,000 satellites. Now, everyone hears the number 70,000 satellites are going to be expected, 100,000 satellites are going to be expected by 2030. Whatever be the number, right? So it is also important for us to ensure that not only we collect data, but also we process the data on board, right? To get meaningful information as soon as we can, and so that decision can be taken. Now, with on the strategic side of things, this has a lot of repercussions or also a lot of applications as well. So what we have seen is there's an increasing demand of processing data at edge. How do we ensure we not only generate the data set, but also extract the data set that is useful so that we can put it in an operational environment? Now that requires a lot of testing. It also requires a lot of analysis, right? So that's one of the areas that we're sort of working towards, where we're leveraging AI and ML to see how do we pick out a needle in a haystack? How do we ensure that satellites are behaving the way that they are supposed to behave? Are there any out of pattern maneuvers? So these are the informations that we try to gather, not only from, let's say, electro-optical data sets, but also radar, stuff like that. So one of the efforts that we have been doing, at least on between, like, as we're talking about India and Finland, a lot of efforts that we have been doing is to leverage space weather data sets. How do we leverage radar data like ISCAT data sets? So we're looking at utilizing these data sets to ensure that we're able to get meaningful solution out of it. So that's another area that's very interesting to us, not only from electro-optical side of things we are looking at, but also looking at how do we not only take the electro-optical data set that we have, but also on the radar data, passive RF data sets to fuse the data together to get better understanding about what is happening in orbit. That's that's one of the areas that we have been doing. But with the increase in applications, what we are also seeing that while we are looking at LEO and GEO as the contested domains, there have also been increasing demand or rather application when we look at XGEO and cislunar. So we are now looking at orbits that have traditionally been not looked at to see how do we ensure that we are able to track objects better, but also predict objects better. Now, with when you're tracking in such exotic orbits, there's a three-body problem that comes into picture. So these are the areas that we are looking into the future that needs to be solved. So these are something that we at Digantar are actively working on. Primarily to not only cater to the current demand, but also to cater to the demand that we're looking at the market from 5 years down the line. So essentially, to sum up the capabilities that we have, while on the application side, we're working on easing space operations for satellite operators, or on the strategic side, helping them understand how a satellite, adversary satellite is behaving. The whole focus for us as a company right now is towards building capabilities, better sensing capabilities, better data processing capabilities, but also leveraging new tools like AI/ML to ensure that we are able to understand pattern out of big data sets. So I think I'll take a pause here. If you have any questions, happy to take those questions, answer them. Look forward to hearing from you all. Thank you so much.
Hi, you're done, Shreyas?
Yes, sir.
Thank you. Thank you. I think this is what you have touched upon is a fantastic, good job you're doing. And I think we are proud of you, and you are one of the leading few of the startups, Indian startups, and thanks for what you're doing. And I think you are doing a tremendous good job. And with that note, I would like to move to Dr. Diana Taxi. She will talk about her research. She's a researcher first secretary embassy in Hungary. She will talk about draft EU space regulation from point of small companies and third country service providers. This is a very important issue. Currently, this draft EU space regulation is under the consultation process, and it is it is open for submission. So I think her views will definitely guide us further. So I would like to invite Dr. Diana Dapsi. Dr. Diana? Is she there? Dr. Diana, can you join and unmute yourself? There is some issue with Dr. Diana. So what we'll do, we'll wait for her to come. So we will give her floor once she's available. So now we would like to open floor for question answer, and please raise your question answer in the box or chat box, or maybe you may raise your hand and you please mention about what is your question if it is directed to someone. So now there's a time for interactive question answer session. Yes, Lisa.
Can you hear me now? Yes, I think Dr. Diana is now available. She sent a message, so check that once more. I think that Diana, you are not audible, but let her activate her mic.
Am I audible now?
Yes,
yes, very much. Yeah, please go ahead. No, you're again got a mute. Yes, it's better.
Do you hear me now?
Yes, very much.
Okay, well, I try to. Well, I'm in a hotel, but I do hope that I will be audible for throughout the time. So thank you for the introduction. I try to share my slides, which are here already. So I try to speak about the EU space regulation, because it is a part of my research, and it is recently came out, which will be interesting, and it will probably shape a little bit the whole European Union's view. And sorry, just a second. So the whole European Union's view and the way of satellites will be launched from Europe and providing service for Europe. So I think that will be an interesting regulation for all. So bear a little bit time with me. So I got my slides. So the EU is recently published the regulation, draft regulation about EU space regulation, and that will probably cause a little bit problem with the space actors, especially operators. The basic things what we usually ask if someone wants to have a satellite in orbit, why space is worth it. So although it has very high entrance barriers, frequencies what the satellites are using are limited and scarce resources with the space orbits, heavily regulated both sides. I mean, not just the space law is regulating, also the ITU is also regulating this segment. So it is hard to launch any satellite in orbit. K-orbit positions already in use. Capital investment rate is very high. it should be always a state-of-the-art technology, but as a business, it's always profitable because most of the satellite operators operate with long-term contracts. They also provide an economy of scale. So for the investment, they get a quite high return and also highly profitable and predictable operating possibilities for all those who are in that space. What is the EU Space Act and why it will be new? The EU Space Act will be a regulation, not a directive. So this will be directly applicable for any member countries, so 27 member countries. The aim was to have very well in the last couple of years. 22 of the 27 countries have their own space act, but the regulations are differing. So it is sometimes interfering with the basics of the EU, which is market entrance should be similar to every country. So the goods, the services should be on the same level. And that's why the EU started to think about getting a regulation. So the regulation covers the authorization, registration, supervision, and enforcement of requirements, and also harmonizes and introduces technical, operational, and environmental requirements. One important thing is the space debris. That's what one of the aspects what the EU wants to address with that regulation, and also the space traffic is getting, as someone previously before me told about the congestion. While the space traffic management will be also an issue which will covered by this kind of regulation. So one of the challenges which the regulation will face is that it applies for both EU and non-EU operators providing services in the Union. So with LEO satellites, most of the LEO satellite operators also provide services in the EU. So that will be a challenge for them. And also we should see it as a strategic, geopolitically, it has a strategic context, that regulation. So the EU wants to have the joint independent capabilities of the various European countries join together and have a really resilient and standardized space governance for all countries. So that the space objects and those space objects which are used for defense or national security are not part of that Space Act, what the EU proposed, which is aligned with the previous space possibilities. And also there is a deadline that no space assets, they were launched before January 1st, 2030. So the entities which this new kind of regulation covers are very interesting also. It comprises from the space operators, also for those collision avoidance service providers, which are getting in the number very high. Primary providers of space-based data, probably most of the people who were speaking before me would be interested in that. And also international organizations are excluded, or included, sorry. And several third country operators, for example, it targets mostly SpaceX and the US space industry, who are providing services and data in EU. So GPS also part of that. But also the entities can be not directly contacted with the EU Space Act, but they are supplying product components. They can be also affected in two different ways. The Act also wants to have that the companies who are using these kind of supplies make their suppliers comply with the provisions of that EU regulation, and and also back-to-back requirements for streamline the compliance and reduce risks. The key areas of impact are what we have already saw in the draft regulation is that the EU wants to have high product standards, wants to implement cybersecurity in the space assets as well, and also they want to have the data of environmental data to provide footprint calculations and environmental assessment. So that will be a challenge to provide for the EU registration, because they are setting up also a special registration system for those space assets and space providers. What we have so far indicated that new regulation will impact space data and services, not just satellite communication, navigation, Earth observation, and remote sensing, but also launch services and operators, collision avoidance and in-space servicing, data protection and downstream applications, cross-border activities as well, like in multiple member states or third countries who are in the EU market. The draft regulation sets up an authorization and registration procedure, which one is applicable for EU-based service providers. They are submitting their application to a member state authority. There is one exception in that if the space object is operated by USPA or owned by the EU, then there should be various data provided for that authorization, and also there should be an assessment. Oh, sorry, I just did something wrong, I think, with my presentation. Yeah, I was here. So there should be designated qualified technical bodies who make an assessment on all the technical data provided by the operator, by the national authorities, and the decision period for providing licenses should be at least 12 months. For the third countries, the provisions are interesting also, because the application should be go to the USPA authority, which is already established, and it is in Prague, with two alternatives: either equivalence decision or detailed USPA assessment of requirements. The equivalence decision depends on from which country the operator comes from. And this detailed assessment of requirements will be decided after the regulation was adopted. So, and there are also special provisions for example, simplified procedure for constellations, light regime for research and educational institutions. There is also the principle, what I previously mentioned, the principle of free movement, mutual recognition of authorization issued by other EU member states, which is the basic of the European Union. It's only within the scope of the EU, and stricter requirements can be also applied in that. But one thing is for sure, that is no full harmonization in this field. And I already talked about the registration and demonstration of equivalence for the third country members. I think I will conclude here, because I want to emphasize that this is a draft regulation which is now under public consultation. And probably the member states, all, especially those who are active in space, like Finland, will have their national opinions sent to the European Union, because these kind of very strict regulation probably will affect the market position of the European Union itself, and probably not on the best way. So thank you for your attention, and I'm happy to have the questions what you may have.
Yeah, thank you, Dr. Diana, for covering the EU new regulation, which is right now in consideration. It has got certain few nuances which I think we have to look at it. This is one of its own kind of space regulation. So we will be also submitting our response from India as an industry association. So we have taken a note of your presentation. There are a lot of good points which you have just highlighted. I believe there is a direct question for you right now. I can see there is a one. This is the question to Dr. Diana Dagzi. The US has cut short the timeline for satellite operators to remove the dead satellites from 25 years to 5 years. Is there any possibility that EU also aligned to this?
The EU wants to have their own regulation. It's not in the Space Act, but in the draft space regulation. But they are aiming to have a generalized regulation for space traffic management. And space traffic management also covers the removal of space debris. And the EU wants to have it as one of the UN General Assembly's decision as part of the space conventions. So it's a different level. When the EU wants to have their regulation is only for 27 countries, and if the EU wants to propose it on an international forum like the UN General Assembly, it applies all the members of the UN. So 193 countries, 194 countries actually. So if the UN Assembly takes the note on that, because I know that the UN Post also has that issue on that on the table, and they are discussing for quite a long time by now with the space traffic management. So probably there will be much broader possibilities than in the EU regulation, because as I said, I want to emphasize again, the EU regulation only for 27 countries. And in that 27 countries, it's not Russia, no China, no Japan, no Korea, and those are the spacefarer countries. So that's why I think it is it should be on another level. Thank you.
Thank you, Dr. Diana. Is there any question? Now we can move to question thing. We have few time left for to receive some question. Please raise your hand, or you can use chat box for question answer board. You can just raise. So there is a general question from Naveen. He said anybody can, all the speakers can pick up. What areas in space debris management are promising to look at with India, Finland, and otherwise broadly industry collaboration?
I can just make a quick comment on this.
Please.
Yeah, I mean, one of the areas that is of interest is how to not, first of all, removing the debris is one thing, but how can we reuse the debris in space itself? So recycling materials in the context of manufacturing in space for space, of course, capturing the debris is one challenge, but once I capture it, can I reuse it in space? Can I convert that into feedstock, or is there any other way to reuse it, for example? So that would be an interesting topic to work on as well. Yeah, thank you.
Thank you, Dr. Satya. Is there any other question? So if not, then I will. I'd like to request Lisa to close this. Today is a very interactive, very interesting webinar. I think we like to conduct such a webinar in future to exchange knowledge about the space activities in two countries, and it was very exciting. And now I will like to invite Lisa for his last closing comments. And I'll request everyone who has present kindly open your video, so at least we can take one photograph of the group. So we can take. So yes, Lisa, over to you.
Okay, thank you, and thanks a lot for everybody who was talking today. I think that at least to me, it was super exciting and really many new things to me. And I hope that also for many people who participated today. And as you know, this is also recorded, because, for example, in Finland, it unfortunately happens to be an autumn holiday for school kids. So many of the parents are also on a holiday. So we would like to provide them a possibility to look at this very important webinar later on. And as it was suggested already here by by Dr. Vinod Kumar, for example, and also others, that we should somehow continue cooperation in this space sector, because it concerns not only rocket science and satellites, but all the other sciences which are connected somehow or are utilizing all this information and possibilities we will get through satellites and space sector as such. And one suggestion was to probably organize a space day jointly between Finland and India, maybe other European Union countries as well, but at least Finland, India, and it sounds very interesting to me. So just to be short, thanks a lot, and thanks for spending your Friday afternoon with us, and hope to see you again. And a special thanks, of course, to Indian Space Industry Association, who took most of the troubles and organizing here. So many thanks for all of you.
Yes, thank you, Lisa. A pleasure of ours, and wish you all a very happy Diwali, a prosperous Diwali. And in the chat, I have mentioned about two events which you can look at it. That's the DevSet and India Space Congress in next year, February and June. And Lisa, probably we could celebrate in one of these events as a Finland or India Space Day.
Oh, yes, yes, we can. We can, of course, and we will send everybody who are registered also this recording of this space seminar. And happy Diwali from my side as well to everybody.
Thank you very much. Thank you.
Thank you. Thank you very much.
Thank you very much for all. Bye.
Thank you. Bye bye.
Okay, see you.
Bye.